Welcome Statistics 1 students, this is week 5 of maintenance. We're still going over the representation of data, work that we've done, and the first one is a past exam question on coded data. So we have a summary of 30 values, so this here is our n, of x, and it gives us the following information: the sum of each value of x subtracted by a value c adds up to give us 234, and then each of those values squared and added up gives us 1957. So we've got to find the standard deviation of these values of x. Now remember, the standard deviation of coded data when we're just adding or subtracting like we are here is going to be the same, because as we move the data down by subtracting, the spread remains the same. So the spread is the same, which means the standard deviation is the same, because the standard deviation is a measure of that spread. Okay, so now remember our formula. So the standard deviation is equal to the square root of the sum of x minus c squared all over n minus the mean. So in this case, that's the mean, but in this case, how do we find the mean of this data? Well, we're going to take all of the values of x minus c, and then we're going to divide that by n. Now, the mean squared. So, the mean squared. Now, let's chuck in our data here. So, it should be the square root, and we're going to have 1957.5 over 30 minus, now, whatever this mean is. So, the sum of all of the values, subtracting c from each one, is 234, and we divide that by n, which is 30, and we're going to square that. Now, when I chuck this into my calculator, what do I get? Oh, bother, I'm in the wrong mode. Okay, square root 1957.5 over 30, subtract, and we'll pop this in brackets, 234 over 30, and we're going to square that value. Now, this is giving me an answer of 21 over 10, which is 2.1. Okay, so the standard deviation is 2.1. Given that the mean of these values is 86, find the value of c. Okay, so the mean of the values is 86, find the value of c. So what we've got to do is take, so the mean is represented by sum of x over the number of items of data, and that's equal to 86. So that we know that the sum of x, therefore, should be equal to 86 times 30, which gives us 2,580. Okay, now what we can do is we can compare this value here, sum of x, and we can compare it with the sum of x minus c. And you know that we've taken away c 30 times. So if we go 2, 5, 8, all right, why have we taken away 30 times? Because there are 30 items of data up here, and we take them away from each of the items of data. So we take 30 away, we take c away 30 times. So if we take away 30c from the sum of all the x values, we should get 234. Now if we just rearrange this so we could bring the 234 across to the left-hand side by subtracting, we get 2346, and then we bring the 30c across by adding 30c to both sides. We get 30c here, and then if we divide both sides by 30, I'm getting 78.2 for c. Okay. Now let's move on to the second question here. We have a stem and leaf diagram. A stem and leaf diagram. Males and females are salary groups. Okay, and we've got to find the median and the quartiles of the females' salaries. Okay, so 39 females. So you want to go find midway point. So half of 39. Which is the midway point? Well, we know that if we divide that by 2, we're going to get, what's that, 19.5. And so we want to find the 20th item of data, and that would be the central piece of data. So let's go and do that now. So you can use, these can help you along the way. 4 and 9 is 13, and 7 is 20. So I think it should be this one here. That's the 20th item of data. So there should be 19 below it. So let's just check. 13, 14, 15, 16, 17, 18, 19. Yeah, I've done it right. Okay, so that's our median. So median. And if we use the key, what does that mean? 22,700. 22,700. Okay, perfect. Perfect. Now, we're going to look at the quartiles. So we need an upper quartile and a lower quartile. Now, what we do, if you notice at the bottom, underneath the median, we've got these, and there's 19 values. Okay, so what we do is we divide 19 by 2, and that gives us 9.5. So we want to find the 10th value of data, 10th item of data. So we start from the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think it's this one here. So the lower quartile is equal to 21,700. And we do the same with the upper quartile. And you can count up from the 7 here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the upper quartile looks to me to be, what's that, 24,000. Okay. It's a bit messy, but that'll do the trick. Okay. Now we're going to represent this in a box and whisker graph. So what we'll do, along the bottom, we will have our money. So 19, 20,000, 21,000, 22,000, 23,000, 24,000, 25,000. What do we go up to? Oh, perfect, 26,000. Okay. So salary in thousands of dollars. And okay, we'll do let's do the males one first. So you look at their lowest value, which is 20,300. So each of these little squares is worth 200. So 20,300 would be here. And then you look at the male's lower quartile, which we're told is 22,600. So at 22,600, which is here, I'm going to draw my line so it goes up and here. So, and we'll have a line joining the lowest value to the lower quartile. Now the median is at 24,000, so I've got a line. Oops, I'll try and keep this accurate. Here we go. We join that part of the box up there. And
okay, anyway, now let's just quickly try and do the roll. Okay, so Aria, yeah, all right, Kana.
Then we're going to join that up with the upper quartile. Sorry, I just got distracted because a school class came on my Zoom session while I was trying to do this. Okay, and we'll go up to 25,300 as our upper value, so that would be there. So that's the male salary information. Oh no, sorry, that's not, that's my upper quartile. Sorry, I shouldn't have a line there. That comes with being distracted. It should be what are we, 25,300? So it should be about there. Okay, align there. Now we join that box up there. Okay, obviously you do this with a ruler. And the highest most value is 26,600. So that would be approximately, it would be there. Okay, so I just join that up. So that's the male salaries. Let's look at the ladies. Oh yeah, we'll do that in pink. Okay, so the lowest value for the ladies, the females, is 20,000. So slightly lower there. 20,000. And then the median, the lower quartile is 21,700. So the lower quartile should be, where's 700? That's about here. So we go to approximately. I haven't quite got that right. It's quite hard on this tablet thing. Okay, join that up there. Then we go to the median. The median is 22,700. So 22,700 is here. Okay. And then we go to the upper quartile, which is 24,000 for the females. So upper quartile. Yep. And yep. And then the highest value for the female earning is 26,500. So 26,500 is approximately there. So there we go. And then I'll probably go, maybe I'll go females. And I'd go males here. Okay. Can compare the data, I guess. Well, looks like there's a slight skewing here. There's a bit more. The top 25% is quite elongated there, isn't it? Okay, that's all we had to do though. We just have to represent it, so no big deal there. Okay, moving right along. Okay, so the next one, we've got a set of 10 items of data. So this looks like a coding question again. We've got to find the mean and standard deviation. Okay, well, let's find the standard deviation. We know that the standard deviation does not change when we code the data by just adding or subtracting a number to each item of data. So we know, therefore, that the standard deviation in this case is equal to the square root of, and we'd take the every value, subtract 20 and square them and add them, over the numbers of items of data. So we've got 10 items of data. Then we're going to do the mean squared. Now, the mean squared. Well, what is the mean squared? Well, in this case, we are going to add up all of the items of data, subtract them by each one by 20. We're going to divide by the number of items of data we have, and then we square it. And that would be the mean of the coded data. Okay, now we're getting the standard deviation of the coded data now, which is exactly the same as the standard deviation of the non-coded data. So let's get that. So we get square root, and we'd have 2,050 all over 10, subtract minus 140 all over 10, and we square that, and let's see what we get when we chuck this into the old calculator. 2050 subtract minus 140 over 10, and we're going to square that. I'm getting that the standard deviation is, in fact, 3. Alright, now how are we going to go about finding the mean? Well, if that is the standard deviation of the coded data, then the standard deviation of the non-coded data will look like this. So let me draw it in. Okay, it would be the sum of x the sum of x squared over, no, actually I don't think we even need to go to that trouble. We can just think of it like this. If the mean of the, what is the mean of the coded data? It's equal to the sum of x minus 20, divide by 10. And so that's negative 1.4, I think. Oh, sorry, negative 14. All right, your data is up here that we're using for that. Okay, now, since we've been subtracting 20 from everything, the mean is going to shift by 20. So we're going to go mean of uncoded data equals minus 14 plus 20 equals 6. Okay, so just remember all that's happening is when you code data, everything shifts. So let's say, I think I've done this diagram before, we've got some data like this, and let's say that our mean is approximately here, right? And if we shift this data, okay, let's say we shift everything to, by minus 20, we go over this way, right? To get back from that mean to the original mean, we just add 20. So that's all I'm doing here. All right, I think that's all for today, folks. So I hope that makes sense. I hope it wasn't too confusing for you. All right, guys. God bless. Take care.